Hello students, today in this video lecture I will discuss on the topics viscosity. Now at first, what is viscosity? Viscosity is a property of fluid that's mean for both liquid and gases. Now for understanding the viscosity, at first I am discussing the matter considering a liquid. When a liquid flows slowly and steadily over a fixed horizontal surface, its layer which is in contact with the fixed surface remains stationary, and that is due to the adhesive force between the solid and the liquid. The velocity of each layer gradually increases with its distance from the fixed surface. Now, what does this mean? We consider this is a fixed horizontal solid surface. Now, when a liquid flows over this surface, then the liquid which is in contact with this surface, that liquid will remain at rest. Why? This is due to the adhesive force between the liquid and this solid surface. Now, if we gradually go in the upward direction, then the speed of the liquid will gradually increase. Here, this is the top surface of the liquid and it is flowing with maximum velocity, and this surface is at rest and the velocity is gradually increasing if we go in the upward direction. অর্থাৎ যদি আমরা দেখি একটি দৃঢ় কঠিন কোনো মাধ্যমের উপর দিয়ে কোনো তরল প্রবাহিত হচ্ছে, তখন তরলের যে স্তরটি কঠিনের সংস্পর্শে থাকে, অ্যাডহেসিভ ফোর্সের জন্য সেই স্তরটি স্থির অবস্থা থাকে এবং এই কঠিনের তল থেকে যত আমরা দূরে যাব তত দেখতে পাবো যে তরলের গতিবেগ ক্রমশ বৃদ্ধি পাচ্ছে and ওপরের স্তরে গতিবেগ সবচেয়ে বেশি. Now, if we consider any two consecutive layers of the liquid, it is observed that the upper layer moves faster whereas the lower one moves slower. অর্থাৎ যদি আমরা এখানে যে কোনো দুটো লেয়ার কল্পনা করি, দেন উপরের লেয়ারটা বেশি গতিবেগ নিয়ে যাচ্ছে এবং নিচের লেয়ারটা কম গতিবেগ নিয়ে ফ্লো করছে. Now, due to the cohesive force between the liquid molecules, the faster layer tends to accelerate the slower one. অর্থাৎ যেহেতু আমরা জানি যে তরলের কণাগুলির মধ্যে একটি কোহেসিভ ফোর্স কাজ করে, সেই কোহেসিভ ফোর্সের জন্য একটি লেয়ার অন্য আরেকটি লেয়ারকে আকর্ষণ করে এবং এই কারণের জন্যই ফাস্টার লেয়ার উইল ট্রাই টু অ্যাক্সিলারেট দ্য স্লোয়ার ওয়ান, অর্থাৎ বেশি গতিবেগ সম্পন্ন স্তরটি কম গতিবেগ সম্পন্ন স্তরটির গতিবেগ বৃদ্ধি করার চেষ্টা করবে. Whereas the slower one tries to retardate the faster one, অর্থাৎ যে স্তরটির গতিবেগ কম সেই স্তরটি বেশি গতিবেগযুক্ত স্তরটির গতিবেগ কমানোর চেষ্টা করবে. In this way, the liquid layers try to reduce the relative velocity between them. Therefore, on every layer of the liquid there will be a net resistive backward force. অর্থাৎ এই কারণের জন্যই প্রত্যেকটি তরলের স্তরের উপর একটি resistive backward force কাজ করবে. This kind of resistive backward force also arises during the motion of gaseous medium, as I have already said. So this is the property of fluid. So from this we can define viscosity as the property of a fluid by virtue of which different adjacent layers of the fluid oppose the relative motion among them is called viscosity. অর্থাৎ প্রবাহীর যে ধর্মের জন্য প্রবাহীর বিভিন্ন স্তরগুলি তাদের নিজেদের মধ্যে আপেক্ষিক গতিবেগ কমানোর চেষ্টা করে, সেই ধর্মকে বলা হয় সান্দ্রতা. Here, if we consider that this is the layer which is at a distance x from the fixed surface and it is flowing with velocity v, and this is another layer which is at a distance x plus delta x, and it is flowing with velocity v plus delta v. Then we can find out the rate at which the velocity is increasing from this distance. Now that rate of change of velocity with distance is represented by one term that is called velocity gradient. Therefore, what is velocity gradient? The rate at which the velocity of different layers changes with distance perpendicular to the direction of velocity is called velocity gradient. অর্থাৎ ফিক্সড তলটি থেকে দূরত্বের সাথে গতিবেগ যে হারে বৃদ্ধি পায় তাকে বলা হয় velocity gradient. So it is given by delta v by delta x. Since for delta x distance the change in velocity is delta v, so the rate will be delta v by delta x. So velocity gradient is delta v by delta x. Now what is the unit of velocity gradient? And we see delta v, this is the unit of velocity, meter second inverse, and the unit of distance is meter, so here it will be second inverse. And what is the dimension? The dimension of the velocity gradient is time inverse. Since the unit is second inverse, so easily it can be understood that the dimension will be time inverse by t inverse. Next, velocity profile. What is velocity profile? The curve which shows the variation of the velocities of different liquid layers with the distance from the fixed surface is called velocity profile. Here this line represents the velocity profile. Why? You see here along this axis I am drawing the distance from the fixed surface, and along this axis I am drawing the velocity of the liquid layers. Then this curve represents the variation of velocity with distance, and this graph or this curve is called velocity profile. So the curve which shows the variation of velocities of different liquid layers with the distance from the fixed surface is called velocity profile. Here it is the velocity profile. Now if we consider the liquid is flowing through a tube. In the earlier case I have discussed that the liquid was flowing through a horizontal surface. Now here if I consider the liquid is flowing through this kinds of tube, then the variation of velocity will be like this. At the middle the velocity will be maximum, and if we go readily in the outward direction then the velocity will gradually decrease, and the layer which is in contact with this tube that will be stationary. So in this case the velocity profile will be like this. Next, Newton's law of viscosity. If we consider different liquid layers, suppose there are two liquid layers, the area of contact in between them is a, the distance between them is delta x, and their velocities be v and v plus delta v. So their velocity gradient will be delta v by delta x. Now what is the viscous force in between these two surfaces? According to Newton's law, the viscous force between the two layers is number one, directly proportional to the area of contact, that's mean F is proportional to A, and directly proportional to the velocity gradient, that's mean F is proportional to del V by del X. Therefore you can write that F is proportional to A into delta V by delta X, and hence F equal to eta A delta V by delta X, where eta is a proportionality constant and it is called coefficient of viscosity. Here the term F by A is called viscous stress or shearing stress. From this expression it is clear that F by A is proportional to delta V by delta x. So F by A, that's mean the viscous stress is proportional to the velocity gradient. Now the liquid for which viscous stress is proportional to the velocity gradient, those liquids are called Newtonian liquid, and for which this relation is not valid, those liquids are called non-Newtonian liquid. Next, I am defining coefficient of viscosity. Now from the previous lesson, we get F equal to eta A delta V by delta X. Now in this relation, if A equal to 1 and del V del X equal to 1, then we get that eta equal to F. That's mean for unit area of contact and unit velocity gradient, the viscous force is equal to coefficient of viscosity. So you can define the coefficient of viscosity as the coefficient of viscosity of liquid may be defined as the viscous force acting per unit area at the surface of contact between the two layers of a liquid when the velocity gradient in between the two layers is unity. অর্থাৎ তরলের দুটি স্তরের মধ্যে একক গতিবেগের নতিমাত্রা বজায় থাকলে তাদের প্রতি একক ক্ষেত্রফলে যে পরিমাণ viscous force কাজ করে তাই হলো ওই তরলের coefficient of viscosity, and this may also be the case of gaseous substance. Now what is the unit and dimension of coefficient of viscosity? From the above relation we can show that eta equal to F by A into del V by del X. So what will be the unit? So the dimension is given by dimension of F over dimension of this quantity. That's mean ml t to the power minus 2 by m in L square, and del V del X, it has already been shown in the previous page, it is t inverse. So the dimension becomes m L to the power minus 1 t to the power minus 1. Hence the CGS unit is given by dyne second per semi square. This is obtained from this relation, you see. Similarly, if we calculate this unit from this relation, this will be gram centimeter inverse second inverse. So this is gram centimeter inverse second inverse. This is also called Poisson and represented by the term P. In SI unit, the unit is Newton second meter to the power minus 2 or kg meter inverse second inverse. Now here this is Newton per meter square. That's mean this may be called as Pascal. So this unit may also be called Pascal second. This unit is also called decapoise or poisson. The relation between them is 1 decapoise equal to 1 poisson equal to 10 poise. That's mean 1 decapoise equal to 10 poise. Now Stokes law. What is Stokes law? If we consider a solid sphere falling through a viscous medium, then when it is falling, then the liquid molecules which are very close to this surface, they also falls with this sphere. Why? This is due to the adhesive force between the liquid molecules and the solid. Now if we consider the liquid molecules which are far from the solid, then there is no adhesive force. So there is a relative motion between different liquid layers, and due to this there will be a viscous force in the upward direction. So a viscous force F acts in the upward direction against this motion. Now according to Stokes law, the resisting force F due to viscosity acting on a small sphere of radius r falling through a liquid of infinite extent is given by F equal to 6 pi eta v r, where v is the velocity of the sphere, eta is the coefficient of viscosity of the liquid, and r is the radius of the sphere. Now, the Stokes law can be derived using the principle of homogeneity of dimension analysis. At first, we consider that the resistive force F depends on eta, V, and R. That's mean on the coefficient of viscosity of the liquid, the velocity of the sphere, and the radius of the sphere. Now let F is proportional to eta to the power A, V to the power B, and R to the power C, where A, B, and C are arbitrarily chosen constants. Therefore, we may write that F equal to K into eta to the power A, V to the power B, and R to the power C, where K is a dimensionless constant. Now, according to the principle of homogeneity of dimension analysis, the dimension of the left hand side will be equal to the dimension of right hand side. So, dimension of F is equal to dimension of this quantity. The dimension of F is given by ml t to the power minus 2. K is dimensionless, and dimension of eta is ml to the power minus 1 t to the power minus 1. Dimension of V is L t to the power minus 1, and dimension of R is L. Therefore, we may write it is m to the power A, L to the power it is minus A, it is minus B plus C, and t to the power minus A minus B. Now, comparing the dimension of both sides, we may write that A equal to 1. Why? Here the power of m is 1, here the power of m is A. So it is A equal to 1. Similarly, minus A plus B plus C, it is equal to also 1, and minus A minus B equal to 2. Now, putting the value of A equal to 1 in this equation, we get B equal to 1. And putting the value of A and B here, we get C equal to 1. Therefore, A equal to 1, B equal to 1, and C equal to 1. Therefore, we write it is F equal to K eta to the power 1, V to the power 1, R to the power 1. That's mean K eta V R. Here, the value of K can't be found from this dimension analysis. It can be found experimentally. It will be 6 pi. Therefore, the force will be 6 pi eta VR. Now, terminal velocity. Initially, the downward force is larger. Upward force, that's mean the sum of the viscous force and buoyant force, the sum of these two forces is smaller. Now, as the body goes downwards, its velocity gradually increases due to acceleration. Since the viscous force is proportional to the velocity, therefore, as it goes downwards, its viscous force gradually increases. And once the total upward force become equals to the total downward force, and at that time there will be no acceleration. That's mean the body will move with uniform velocity. Therefore, if a spherical body falls freely through a viscous medium, initially it falls with an acceleration due to greater downward force. But after some time, when the upward and the downward force become equal, the body falls with a constant velocity. This constant velocity is called terminal velocity, and it is represented by Vt. Here, terminal velocity is Vt, radius of the ball is small r, density of the liquid is rho, density of the sphere sigma. Now, at equilibrium, total upward force equal to total downward force. That's mean upward force are sum of viscous force and buoyant force, অর্থাৎ viscous force এবং প্লবতা বল, that is equal to weight of the sphere. Now, the viscous force is given by 6 pi eta Vr, where V is Vt here. Weight of the body is its volume, that is 4 by 3 pi r cube, volume into its density, that will give you mass into g. So we shall get the weight. And the buoyant force, what is buoyant force? অর্থাৎ প্লবতা বল কি? This is the weight of the liquid displaced by the solid body. That's mean the volume of the liquid will be equal to the volume of the sphere, and the mass of the liquid will be into its density, and for weight we are multiplying g. So total buoyant force is 4 by 3 pi r cube rho g. Therefore this equation may be written in this way. Now this may be also represented as this. Therefore Vt will be equal to 2 by 9 r square sigma minus rho g by eta. So this gives you the expression of terminal velocity. Here you see the terminal velocity is proportional to radius square, and it is inversely proportional to eta. If we draw a graph showing the variation of velocity with time or with distance, then we shall see these kinds of graph. And initially with time the velocity gradually increases, but after some time you see velocity become constant, and that constant velocity is Vt. Next, effect of temperature on viscosity. For liquid, coefficient of viscosity of liquid decreases rapidly with the increase in temperature. অর্থাৎ তাপমাত্রা বাড়ানোর সাথে সাথে তরলের viscosity ক্রমশ কমতে থাকে. Why? In case of liquid, the cause of viscosity is the cohesive force among the liquid molecules. Now, if the temperature increases, then the intermolecular distance also increases, and hence the cohesive force decreases. Therefore, the viscosity of liquid decreases with the increase in temperature. অর্থাৎ তাপমাত্রা বাড়ার সাথে সাথে লিকুইড মলিকুলগুলোর মধ্যে দূরত্ব বেড়ে যায় এবং তার ফলে কোহেসিভ ফোর্সের মান কমে যায়, and for that reason the viscosity also decreases. Now if we consider the case of gas, then for gaseous substances the coefficient of viscosity increases with the rise in temperature. This is exactly opposite to that of the liquid. Why? In case of gas, the cohesive force is negligible. The cause of viscosity is the collision among the gaseous molecules, or the momentum transfer among the gaseous molecules. Now, if the temperature increases, then the velocity of the gas molecule increases, and hence the randomness of the molecules increases. Therefore, the intermolecular collision also increases. Therefore, the velocity of the gas decreases with the increase in temperature. অর্থাৎ গ্যাসের ক্ষেত্রে ভিসকোসিটির কারণ হলো collision among the gaseous molecules. যখন তাপমাত্রা বাড়ানো হয়, গ্যাসীয় অণুগুলির গতিবেগ বৃদ্ধি পায় এবং তার ফলে তাদের মধ্যে কলিশনের সংখ্যা বৃদ্ধি পায় এবং তার ফলে ভিসকোসিটি বৃদ্ধি পায়. So that's all for the day. Thank you.